Nederland, waterland. Netherlands, waterlands. It's a common saying that we use here to describe our country. Some of our biggest challenges, but also some of our biggest victories, were because we had to protect ourselves from an extreme excess of water. The bigger the shock to us when we realized that we are a country that suffers from water scarcity.
This water scarcity, caused by overpopulation and global warming, impacts everyone. The industry, the agricultural sector, and even the production of drinking water. This may sound confusing because there is so much water in the world, but we only use so little. That is because most water is salt water, and we are not yet able to desalinate this water in a sufficient and a sustainable way. A sector that deals a lot with this issue is the horticultural business. This sector is responsible for most of the flowers, fruits, and vegetables you see every day. For them, we researched a new biological method of desalination, algae.
There are many species of algae all around us, with all of them having different uses. So we thought they could be a potential solution to our problem. During our research, we looked at 3 different halophilic algae. These algae need salt to survive. We looked at the Sandesma species, the Chlorella vulgaris, and Dunaliella salina. In theory, we could use these algae to absorb sodium from the water, sodium being the main compartment of salt. To investigate and prove this theory, we conducted 3 examinations. We put different species of algae into 8 tanks with different sodium concentrations. Then we measured the practical sodium concentrations over a period of 5 weeks. After these 5 weeks had passed, we calculated the sodium intake by the algae. Then we did a microscopic research to determine the algae in the tanks. And finally, we investigated the growth of the algae using the light transparency of the water in the tanks.
Three conclusions could be drawn from these results. Firstly, we can say with certainty that it's possible for the Chlorella algae to absorb sodium. Secondly, it appears that the more algae is present in the tank, the more sodium in the tank is absorbed. And finally, it turned out that the algae also started to absorb more sodium when the concentration of the sodium in the tank was higher. Based on this last conclusion, we could therefore state that algae as a desalination method is more suitable for water with a higher sodium concentration than for the greenhouse horticulture.
We see a promising future with algae as a new desalination method. Using algae has distinctive benefits. First of all, we can use it to make biofuel, and we can also use it to make nutritional supplements. This offers the opportunity to use this biofuel and make the process circular. Or it could be used by the community. Algae also emit oxygen instead of carbon dioxide. This makes the process sustainable and in accordance with the guidelines of the Sustainable Development Goals. This desalination process with algae is beneficial to people and planet. And we can conclude that this green gold defeats the salt!